Hi class, I just wanted to make clear on polarization, repolarization, depolarization. So what we discussed today in class, I saw that it was kind of confusing. Alright, so let me explain it. So here's a cell membrane, right? Outside of the cell, we have more sodium, right? So this is extracellular space, and this is intracellular space. So outside the cell we have more sodium and we have less potassium, right? But they're all positive ions. So we also have some other ions like chloride, for example. But inside of the cell we also have sodium, but we have less sodium and we have more potassium. Right? So the charge is moving from one side of the membrane to another side based on the concentration gradient of each electrolyte, or based on polarity. Pluses will move towards the minus, or the minus will move towards the plus. So at the resting membrane potential, that's when the membrane is charged. So if you look here, the membrane inside, intracellular, is minus 70 millivolts. And then when the action potential arrives, this membrane will discharge. Here we have sodium channels and let's say potassium channels, right? Sodium channels and potassium channels. So now sodium starts diffusing inside of the cell. It goes inside of the cell. So it's positive, and inside of the cell there's more negative. So intracellular is more negative. By bringing positive, cell becomes more positive, right? So it was minus 70, and then cell gets, let's say, to plus 35 millivolts, because you're bringing a lot of positive ions there. So now it's plus 35. And then that's the depolarization, so that happens right here, right? When the membrane depolarizes. So sodium channels are open. So then sodium channels will close and potassium channels will open. And now potassium needs to leave the cell. Sodium enters and potassium leaves. So now potassium starts getting out of the cell. So the potassium is positive, and inside of the cell now is more positive at plus 35 millivolts. So now just by removing positive, just because it's positive, the cell will become more negative, right? By removing positive, it used to be plus 35, and now it's gonna drop down back, let's say to minus 70, but it's gonna drop down back to 90 millivolts. So it's gonna be hyperpolarization. This was depolarization when the sodium enters, and when potassium leaves, it is repolarization right here, right? We're repolarizing. So now potassium channels are open at this time, but the sodium channels are closed. And with these leaky channels, it's not just the potassium channels, there's sodium and potassium channels. So the potassium leaks out and sodium leaks in. And that kind of balances everything out. So that's how we come back to that resting membrane potential to minus 70. So when another action potential arrives, so that leads again to depolarization and repolarization. So again, it's charge, discharge, recharged, polarized, depolarized, or repolarized. So to summarize, again, that's the membrane outside of the cell more positive, inside of the cell more negative, right? Positive sodium flows in, right? And this minus 70 being positive, it becomes plus 35 approximately. So now we have potassium, and potassium is positive. Now when the potassium exits the cell, you're removing positive ions, and that's how you are able to go back to this resting or initial state to minus 70. Well, it dropped to minus 90, but the potassium keeps leaving and some sodium will enter, and that's why we can reestablish the differences between 90 and 70 by moving these positive ions, which are both positive. But do not forget that inside of the cell we also have bicarbonates. This is negative. Let's say outside of the cell we have negative chloride. There's also inside of the cell negative proteins. So that way the cell is able to reestablish its resting potential.